Good evening, everyone. Welcome to NEPTAL online certification courses offered by Indian Institute of Technology, Kharagpur. Course name is Design of Reinforced Concrete Structures. Myself, Danish Bashir, PhD scholar from IIT Madras, Department of Civil Engineering. Today, I will be discussing the problems given in the week 0 assignment. The first question of the assignment is, what is the maximum bending moment that occurs for a cantilever beam under UDL? From the right hand side, you can see a cantilever beam subjected to a downward UDL load. If we see the bending moment diagram, from the bending moment diagram, we can clearly see that the bending moment diagram has a maximum ordinated support as WL square by 2. So the option A will be correct. At support, it is having the of experience the maximum bending moment. And the second question is related to the shear force. Same, if we see this shear force diagram, SFD of the cantilever subject to a UDL, we can see that the shear force diagram is having a maximum ordinate at the support of the WL. Coming to question third, question third is about the minimum grade of plain cement, concrete, PCC, and RCC structures as per IS code. Here on the right hand side, I have given a table showing the minimum grade of concrete with respect to the different exposure conditions used for both PCC, plain cement concrete, as well as RCC concrete. From the table, it can be clearly seen that if we take the moderate conditions in the plain cement concrete, the minimum grade of concrete to be used is M15 in any case, the column 5. And same for the reinforced concrete under the mild conditions, M20 is the minimum grade of concrete. For the mild conditions in the minimum grade of concrete for PCC, there is no discussion. So we can go with the option M15 and M20. M15 and M20 respectively. That will be the option C will be correct for this question. Question 4 is the compressive strength of 100 mm cube as compared to 15 mm, 150 mm cube is always. So there will be the two approach to answer this question. First approach will be the size effect. If we consider the larger cube, it may have the larger voids or the larger impurities present inside. So this on the size effect, we can see that the larger cube will have less compressive strength as compared to the smaller cube. The reason second, if we apply the same normal load on both the cubes, due to the smaller surface area of the smaller cube, it will show larger compressive strength. Question number 5 is under transverse downward load on a simply supported beam, the tension will be at. Here we can see a simply supported beam acted upon a point load at its midspan. We can see that it is bending like this, and the neutral axis is having no extension, no compression. And we can see that the above surface is compressed. All the fibers above the neutral axis experience the compressive stresses, and all the fibers below the neutral axis experience the tensile stresses. Here we can see that this is a beam modeled and ANSYS software. For there we can see also say that the tensile stresses are at the bottom and compressive stresses are at the top from this contour plot here. Here is a simply supported beam subjected to a UDL flow or transverse. We can see that it's also a transverse downward load. So the tension will be at below the neutral axis. So option B will be correct for this. Question 6 is which of the following stresses can plain cement concrete endure? As we all know, concrete is very cement is very strong in taking the compressive stresses, and if we require to take this concrete or cement to take tensile loads, we need to embed the rebars reinforcement. We have to give the reinforcement. Since it is talking about plain cement concrete, there are no rebars, so it can only endure compressive stresses. It will fail under tension. So option B will be correct. There is question number 7 says that if slump of a concrete mix is 60 mm, its workability is. First, slump test is actually a test to know the workability of a concrete. Actually, workability may be defined as the condition of a concrete to be used at the construction site. Is it workable or not? It depends upon the lot of the factors. And major factor, it indicates that the amount of water added to it, how much workable the concrete is. Here I have added a workability versus slump chart. You can see that easily see that slump value is usually uh, measured in mm. You can easily say that 50 to 100 mm. Our value 60 mm lies between 50 and 100 mm. So the corresponding workability will be medium. Option 7 will be correct. Option C will be correct for question 7. Question 8 says that how many layers of concrete are needed to fill a slump cone? Same question from the slump test. Here is the slump test procedure that I have attached here. If we can see that from the slump test procedure, we see that the steps to be followed are slump cone has to be placed on a hard, non-water absorbing surface. And the second point is the slump cone is filled with freshly mixed concrete in 3 layers. There should be at least 3 layers to be filled in a slump cone to carry out the slump test for a given concrete at a site. So 3 layers will be equal by, and it will be uh, by height. Question 9, unit weight of cement is it's a very simple question. It's ordinary cement. There are different types of cement. So since it is not mentioned here which type of cement, I will go for the cement, ordinary Portland cement. It is 1440 kg per meter cube. Option A will be correct. For a grade of concrete M15, the compressive strength of 15 centimeter cube after 28 days in kg per centimeter is square is, since the curing period has been specified as 28 days, and we know that M15 grade in this, the 15 suggests that after 28 days of curing, the minimum compressive strength that a cube of any size will offer will be 15 Newton per mm square. So if we convert this value 15 Newton per mm square to kg per centimeter square, it will be roughly 150 kg per centimeter square. So the option A will be correct. Thank you.